All right, hello everyone. This week we're going to learn about module 8, which is a new model. It's continuous probability distribution. So last week is discrete and this week is continuous. This is much more difficult, so please bear with me. Of course, we use it for things which can be measured, obviously. For example, we're interested in information such as the percentage of students who travels less than 10 miles. So the continuous distribution, we know that the observation occurs within a certain range. For example, um, the percentage of student who travels less than 10 miles, right? So this is the graph for student who travels, well, 10, the miles student travels, and this is the mean, for example, and this is less than 10 miles, this is more than 10 miles. So yeah, it's continuous, right? A student can travel, 9 miles, 9.2 miles. So it's continuous. You can't put a discrete like value to it. So there's three types of continuous probability distributions. There's uniform, normal, and exponential. Uniform is this one, is the most easy, is the easiest one. Oh, before we start, basically for continuous probability distribution, we are working with areas under the graph, okay? So please remember that. And if I'm not wrong, you're supposed to draw the graph for your exam. So please remember that. You have to draw the graph. So if you want to draw in the first place, you have to understand the concept behind the area under the graph itself. So this is the simplest one. Uniform, this is the simplest one. It's rectangular in shape. It's always rectangular and defined by minimum and maximum values. So y-axis is the probability and x-axis is the values, right? And the area under the graph is height times base, which is 1 per b minus a, where b is the maximum value and a is the minimum value, times b minus a. Well, b is here and a is here, right? And this is 1 over b minus a. Okay, so basically in uniform probability distribution, what's good about it is the probability is always the same. So yeah, mean is a plus b divided by 2, which is the middle point of the minimum and maximum value. The standard deviation is maximum value minus minimum value divided by the square root of 12. This is set, this is fixed. So please remember this formula, or please do bring your module with you in the exam. And the probability of x is always 1 minus b minus a, 1 per b minus a, my bad. So mean, mu is, okay, you know the definition, obviously. In continuous random variable, the area of distribution represents the probability. So the area under the graph should be 1. This is uniform. It always is. So in uniform probability distribution, the probability is the area of the rectangle. As I said before, for continuous distribution, you are always working with the area under the graph. And in this case, the graph is a triangle. Okay, so under blah, 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 average annual cost is 691. So you know mu is directly $691. So suppose automobile insurance cost is uniformly distributed. This is in the question, so don't worry. With a range of 200 until 1,182. What's the standard deviation? What is the height of the distribution? And what's the probability that a person's annual cost is between these values, okay? Okay, so for standard deviation, you know the formula is maximum minus minimum value divided by square root of 12, which means 1,182 minus 200 divided by square root of 12, you'll get 2,835. So you know that the standard deviation is 283.5. This is so small, the dot. The height of the distribution is the probability of x. So 1 divided by 1,182 minus 200. So 0.001. Okay, so you got px and you got the standard deviation. So you're supposed to find the probability that the person's annual cost is between x1 value and x2 value. So you just have to use the formula. And here, area is height times base, and the base is 825, 410 until 825. The height is always the same. Okay, because it's a rectangle. So 0.001 times 825 minus 410, you get 0.415. So 0.415 is the probability that a person's annual cost is between $410 and $825. If you want to draw the graph, as you need to, this is 0.001, right? The y-axis is the probability, okay? And this is the square. So rectangle, my bad. Rectangles always the same height, right? But you want to play with the base here. So this is the minimum value, which is $410, right? This is the oh, no. This is not the minimum value. The minimum value is, as given in the question, it's $200, right? So $200, and the maximum value is $1,182. So if you want to find the probability that it falls between 410 and 825, you draw it like this. So 410 is here and 825 is here, right? And then you sketch it. So you want to find the area of this. That basically is your probability. So this is 0.415, the area. Okay. So the shaded part, the sum of the shaded part plus the sum of the unshaded part should be 1, because the area under the graph in total should be 1. Okay. Now we move on to a standard normal distribution. This is going to step it up a notch, and we're going to use the Z formula. Okay. What is the Z formula? It's basically something to represent the normal graph. It's something to link a normal graph and probability. Okay. X is the value for any particular observation. So it's given the measurement. It's given the question, and the mean is also given the question. And standard deviation, sometimes you have to count it. Sometimes it's given in the question. This probability distribution is called standard normal probability distribution. So this is a normal curve, as I believe you have seen before. If Miss Sandra's lesson actually precedes mine. If mine precedes hers, then this is the first time you're seeing the normal distribution curve. So basically it's a curve. Okay. It's a bell-shaped curve, and in the middle, it's the mean. Okay. So a standard deviation, yada, yada, yada. And this is all the possible values that can come out between the distribution. I know it sounds confusing. If you don't understand, please line me. Oh, by the way, guys, we have a new absent structure. So please listen to the lesson. I will give a certain keyword. Boys and girls have a different keyword. And to get your absence, you have to do your absence, of course, in Teams. And you also have to chat in the YouTube chat box, according to the particular keywords, obviously. So continuing the lesson, Z value expresses the distance or the difference between a particular value of X and the mean, okay? And unit of the standard deviation, Z value is normally distributed with a mean of 0 and a standard deviation of 1. To know a probabilities of standard deviation, we use a list of probabilities in Z table. So I think this is also the first time you guys will be using this Z table. It looks like this, okay? Okay, this is very, very messy, but I will attempt to explain to you guys. So, okay, we have a question. According to a report by Scarborough Research, the average monthly student CAFE bill is $73. So you know directly that the mean is $73. And it's normally distributed. Hence, use the Z table, and the standard deviation is $11.35. So you mark that out directly, right? Don't forget to do that. It makes your life easier, trust me. Okay, so A, what's the probability that a random selected monthly CAFE bills is more than $100? So you're basically asking if P is probability, right? P is probability, my bad. I don't like saying the word probability. PX more than 100. So how are we going to do that? you have to convert it to a Z value. Okay, if you're converting it to a Z value, you use this formula, which is mean, or no, X minus mean divided by standard deviation. What is the X? So the X is the certain value that you are given in the question. So if X is larger than 100, then the X value you should use is the 100, okay? Minus mean is $73, right? And the standard deviation is 11.35. So the Z value is 2.38. So you have to find a probability that Z is more than 2.38, okay? Hence, this I think should be 0.493 413. Okay, so if you want to get wait, I don't think I'm explaining it correctly. Okay, so the Z value for the probability that Z is equal, okay, 2.38 is 0.4913. Okay, if you want to find the probability that the Z is less than 2. Well, no, this is more than, right? If you want to find the probability that Z is more than 2.38, you do this 0.5 minus 0.4913. Okay, this is 0.0087. Now you may ask, why do you have to get 0.5 and then minus it with 0.4913? Of course, and here you have to understand the workings of the normal distribution graph or the bell-shaped curve first. Okay, so this is the normal curve. This is 0. So this represents Z. This is all values of Z, right? Okay, if the Z value is 2.38, which is like all the way over here, okay, the probability that it's less than 0. The probability that it's less than 2.38 is over here, right? It's the part where I'm shading. That's for less than. You always put an emphasis to the left of the graph. So if to the left of the graph is 0.913, what's the area of this tiny little part, okay, which I will be shading with the, I can't change colors really. I can. Okay, which I will be shading with the color blue. What's the probability? What's the area under the graph which represents the color blue? Okay, so this entire right part of the graph. Okay, if you remember correctly, the total area of the graph is 1, right? So the area of half of the graph is 0.5, right? Hence, if you want to get the blue area, it's 0.5 minus the area that is shaded, which is 0.4913. You get 0.0087. Okay. So this is a bit confusing because it might be new for you guys. So we're gonna just do a lot of other examples. So when x is equals to 60, my bad. So 60 minus 73, you get Z value of this negative 1.145. So what if you get negative? Okay, no, come down. It's not the end of the world. We should look at the Z table with the critical value 1.14 and 1.15 because the Z value actually is 1.145, right? It falls between these two numbers. Okay, so the Z for 1.14 is 0.3729, and the Z for 1.15 is 0.3749. So you add that up, divided by 2, getting its average. So that's the P, that Z is equals 1.145. If you already got that, well, that's it. Yeah. So for when X is equals to 83, because in B you're supposed to find the probability that's it's between 60 and 83, right? So between you have to find, of course, two different probability values. Okay, so when X equals to 83, you find the Z value first. You get 0.881. Okay, so the Z value for 0.881 is 0.3606. If you want to find the probability that it's between 60 and 83, you sum up these two numbers. Why do you sum it up? Here, I'll explain. Okay, so basically this is your previous graph. In the middle, you have the mean. If you remember correctly, the mean is 73, right? So 60 is in the left part of the mean. So this is 60. And 83 is in the, well, right part of the mean. So this is 83. You're supposed to find the area of this, right? So, okay. So this is why you sum it up, because you have to sum up this part first. And then you sum that up with this part, making the total, which is 0.6845. Okay, so when X equals to 80, for C, it is between 90 and 80, right? So between 90 and 80, you have to find the probability that's 80 first and it's 90 first. Okay, so the Z value for 80 is 0.6167. The probability. Well, no, the Z value, right? So look at the Z table with the critical values between 0.61 and 0.62. Why? Because the Z value is 0.6167, which is between 0.61 and 0.62. That's why you have to get these two values and then find the middle point. Okay, you've already done it. That's the probability that it's $80. So when it's $90, you find the Z value first. Of course, it's 1.498. And here you can just do it for 1.50. So you get 0.4332. Okay, so then you can get the probability that's between 80 and 90. So how do you get it? Easy, just do the previous one, the big value minus the small value. Okay, so drawing it, you'll get it like this. So this is 73. Okay, this is 80. Okay, and this is 90. Okay, so you may ask, in the previous question, we actually summed up the two probabilities, but why do you have to minus it now? This is why, because both of the X values is larger than the mean. Hence, when you find the shading, okay, it overlaps in the same side of the graph. I know this sounds a bit confusing. Say, I'll just draw it. So the shading for, okay, I can't use the color yellow, just for green. The shading for 80 will be done with green. Okay, so this is the probability that's 80 is 0.23075. This is 0.23075. Okay, and the probability that it's less than 90, because of course you have to put an emphasis on the middle of the graph, right? The probability that it's less than 90 is going to be colored with, well, dark blue. Okay, you start from 90 and then you shade until the middle of the graph. You can see that there is a part of the graph that overlaps, right? Which is the 0.23075. Because it overlaps, you have to count it out because you want to find this, okay? The area of the graph that is between 80 and 90. So to get that, you have to take the area shaded blue, and then you have to minus it with the area shaded green, which is the one less than 80. So you get this value, okay? I hope you understand. And for this one, selected monthly KV bill is no more than 55, so less than 55, right? This should be easy. All right, this is very messy. So the Z value is 1.58, 1.586, which is between 1.58 and 1.59. So you find the p value for the one in between these two, which is 0.4435. So the probability that X is less than 55 is, well, this. Okay. That should be it for this week. Rewatch the videos if you still haven't understand. And this is for absence. This is for absence. So for male students, please reply in the YouTube chat box with the word pineapple. Okay. And for female students, you reply with the fruit kiwi. Okay, thank you guys. This is it for this week's lesson. We will review, of course, next week because this is a very important module. And we also have some uncovered parts. Yeah. Okay, this is it for this week. Do your absence both in Teams and YouTubes, and see you next week.